Okay, here's our first example for solving multi-step equations. On the previous class, we talked about balancing the equations by using inverse operations and making sure that whatever you do to one side, you must do to the other. Multi-step equations are very similar to two-step equations. We're going to use our background knowledge over two-step equations to help us solve this problem. Before you can start, the very first thing you almost always do is simplify. If there's anything you can simplify in the equation, it's always best to do that now. So let's look here. And when I'm simplifying the equation, I'm trying to get it in its least terms possible. So I can combine the 6 and the 7. These are like terms. So this will help me simplify it to where I don't have to do more steps as necessary. So 6 plus 7 is 13. 13 minus 6x. And I'm just going to recopy the same problem over here so that I'm showing my work and I'm keeping everything nice and organized. Keeping it organized will help you out in the long run, making sure that all of your work is easy to follow. Okay, so now I'm ready to actually solve the equation. Before I do it, it's nice to have this bar down the center here. It just keeps everything separate and it makes it very visual of the two different sides. Okay, so my second step to solving them is when you are going to add or subtract. So I'm trying to look at moving these around, and by doing this, I'm going to add or subtract. Okay, so I like to start with the constants. I'm doing all the constants over, and if you notice, we're going to try to get all the constants over here on the right. We're going to try to get all the variables on the left. So let's move my constants first. Well, over here I have 13. 13 is my constant. And technically right now, it doesn't have an operation out in front of it, but we can think of it as positive. And positive is the same thing as an addition. So the inverse of addition is subtraction. So I'm going to subtract 13 from both sides. And I draw that z over there to symbolize that they cancel out. So 13 minus 13 is equal to 0. So there's that z for you. So I'm left with just negative 6x on this side. Now if I go over to the other, whatever you do to one side, you must do to the other. So I'm going to subtract 13 from this side, and negative 3 minus 13 is negative 16. And I'm just going to bring down that negative 8x. Okay, I'm still trying to move everything around right now, so now I'm going to try to get all the variables over here on the left. So that means I need to move this negative 8x. And if I need to prove it to myself that it's negative, remember that we can always add a line and change the sign. But negative and subtraction are the same thing. So I'm going to, if this is negative 8x, I'm going to add 8x to both sides. And so I'm left with negative 8x plus 8x, and there's that 0 again. It's gone, so I'm left with negative 16 on this side. Negative 6x plus 8x is 2x. So 2x equals negative 16. So now I've got my variables on the left, I've got my constants on the right. Now I'm ready to go ahead and try to get my x by itself. In order to do that, I'm going to multiply or divide to get x by itself. So I'm going to divide both sides of my equation by its coefficient. 2 divided by 2. Now, in this case, it doesn't equal 0, but it equals 1. 2 divided by 2 is always 1, so x is now by itself. Whatever you do to one side, you must do to the other. Divide it by 2. Negative 16 divided by 2 is negative 8. So that is my answer. Should be my answer. The way we're going to prove it is always check our work. So we said x is equal to negative 8. If I substitute negative 8 into the equation for every x and solve the equations on both sides, they should equal each other. So I need to now follow the order of operations. Negative 6 times negative 8 is a positive 48. I'm going to recopy my problem. I'm just going to go ahead and solve this side. Now, I could do 6 plus 8 plus 7. I could do that. I could also use the associative property and combine the 6 and the 7 like I did previously when I combined like terms, and that got me 13 plus 48. And when I combine those down, I get 61. Okay, So now let's work out this side. So this side should also equal 61. So let's see if that's true. Negative 8 times negative 8 is a positive 64. Negative 3 plus 64. If I'm adding opposites, I'm really subtracting. So 64 minus 3 is 61. And I take the sign of the greater absolute value, which would be 64. So I have 61 is equal to 61. So both sides of the equation are true. So this solution, x is equal to negative 8, will always solve this equation. Let's go back to our notes, and I wanted to point some stuff out real quick. If you notice over here, I've got the green is to simplify. Everything that I use to simplify is always represented in green. The adding and subtracting is always represented in blue. Now, this is where that multi-step equation part comes in. Typically, in a two-step, we only do this step once, but we actually did it twice when I was subtracting the 13, and then again when I was adding the 8. So typically, in a multi-step, this step is going to be repeated twice, but not always. And then down here at the end, we have the dividing by 2, and that is simplified or symbolized in the red. So this is the first example for the solving multi-step examples. We're going to do another one that's a little bit more complicated, so you can see how that they're related as